In FeatureCamp 2014, we've introduced a number of improvements to the probing process. The first is if I go to the standard probing add-in button, you'll notice that we've got a number of new default values that we can set within the different features. These will be loaded into the user-defined features so that you only effectively need to fill in those values once. The other thing we've introduced is a number of new features for allowing for decision making. So you'll see here I've got a number of features already pre-created, but what we're going to do is going to regenerate these as we go through. So let's have a quick look at our machining sequence and see what we've got first of all. So you can see we've got an initial facing operation. So we clear the face and then we come in and start pre-drilling and then doing a bit of side milling inside that hole, and then we come in with the probe and then we probe the hole before moving on to the next one, and again repeat the process, so cutting that side and then probing again. So what we want to do is we want to put some decision making sequences to decide whether we continue or abort the machining process after the first side. The aim here is of course to just try and establish the fact that we don't want to do any unnecessary machining if we've caused any problems or any issues on the first pass. So if we play through the machining sequence, just have a quick look at the NC code, you'll notice we have a facing operation, then we have all of our side milling operations with the pre-drilling, and then we get to the end of the program. So we need to insert a number of different elements which allow us to control this process. Now before this was a manual process, you would have had to manually create the code to do so. We've now modified this and allowed you to breed in different feature types that you can simply enter the values for. So let's have a quick look at these. I'm going to stop the simulation. First one I want to do is enter a label to just start the process off. So I'm going to go in and say user defined feature, choose next, and then you'll see we've got three new feature types. So we're going to use the bottom one here, which is test jump label. Once I go to next, you'll see that you've got a comment, a remachine flag register, and a label. So the comment could be anything. We could maybe just put that we want start or something along those lines, maybe start bore. And then I can press set and that'll update the comment for the start of the process. The remachine flag register is basically a counter. And we will set this to 0 on this initial label, and then we can start adding to it if we wish to have multiple machining sequences. Finally, we have a label. This will be an N block number that we go to that allows us to search through the NC code, and in this case I'm going to set this to be 11, say set. And I can say finish at this. We do have positioning and so on, but it's irrelevant for this because it's just simply NC code. So I can say finish. Once I've created that, the only other thing I need to do is I want it to be the second thing to happen. I want the face operation to happen first, and then I want this label to happen. So to do this, I just simply go in and change the base priority, and in this case I'm going to set it to 2. So say OK, and then put that up as the second item. Play through my machining sequence again. And we go to our NC code, and you'll notice I have my face operation, and then I have this start bore 101 is equal to 0, and then the block number N11. So now we run through the machining sequence. We then have the probing sequence, so we've already got the probing sequence in there. So this is specific to this Fadal machine. And after we've done the probing, we then want to take the values that were stored by this probing operation and then make a decision based on those. So to do that, we go back into our new feature, user defined feature, and again I'm going to select one of the new items, only this time I'm going to choose the test abort continue remachine. Choose next. So this has a lot more parameters to control, a lot more elements that we want to work with. So the first thing is just the comment. Again, that's what's going to be output at the top of the process. We then have the size, so we want it to be the same size as our hole that we've just machined. So I'm going to use the pick option, and I'm going to say I want to go same as diameter, and in this case I'm going to select the circle in the middle there and say OK. Next we have the tolerance value. Now at the moment this is set to 0.25, so I can drop this down to maybe 0.05. Then we have all of the register values that we're looking for to enter our numbers into. So we have the remachine flag register, we have the nominal value register, the tolerance, and the temporary register. So the temporary register will be used for any kind of logic or processing of these values, and you can update these values. Maybe I want to make this the 103, and maybe I want my tolerance to sit in 104. So we can move those around and it will adjust accordingly. We have the nominal value register, which is going to place this value in there, and then the remachine flag register is basically the counter value that we used in the jump label. So we're using the same value there, and we're going to increment the counter to allow us to do the remachining. As we scroll down, the result register is simply where the probing sequence, the probing macro that's already on the machine, is going to enter the result of the measured size of this bore. Comparison operator is just simply the item that will do the logic calculation with the values. And then we've also got our continue label and our remachining label and our size error label. So these are the jump labels that we wish to go to in order to simply navigate around the program. So I'm going to change my values here from the default. So I want 12 to be my continue label. My remachine label I'm going to enter as 11 because this is the value again I set in the jump label at the beginning because I wish to return to that position. And then finally the size error label I'm going to set to 13, so I'll keep it with my numbered sequence. Finally, we've got an abort label. So this is a label that we can enter at the end of the program to jump to if we wish to abort. We've then got a series of messages that simply get output with each of these. So again, once I'm happy with that, I can say finish and say OK. Move this up to position here, and in this case this is the 5th item, so let's go to our miscellaneous and set our base priority to be 5. If I now play the sequence again, check our results area, and again look at the NC code. So we have our initial starting jump label, note N11 at the beginning of the sequence, and also note that hash 101 is equal to 0 as well. Scroll down, go through our machining process, go through our measurement, and then we get to our label. So here you can see the sequence of the process. So if I just make this a bit bigger. So we set our nominal value in 102 as we did in our decision making item. We then do the logic to decide the difference between our nominal and our measured, and we get that put into 103. We then set a tolerance value, and then we start making the decisions. So the decisions are simply basically identifying if our value is less than tolerance, so i.e. we are within tolerance, go to 12, so that will scan all the way down to N12 and continue machining. If decision 2, if it fails or skips that and it's less than 0, i.e. we've over machined, go to 13. So that skips to N13, and then we get a deprint size error, go to 999. And then if it skips 1 and 2, we then increment the counter, so we go from 0 to 0 plus 1, so that means it's equal to 1. So if it's equal to 1, go to 11, so it runs all the way back up to the top and runs through that sequence again. If we get through these 2 stages again, and we get to this stage and it says if we've added another 1 to a value that's already 1, if we add 1 to it, it becomes 2, so it is no longer equal to 1, in which case it will skip that and go remachine failure and then go to 999. Now at the moment we have no 999, so what we need to do is we need to add this into our sequence as well. So to do that we create another machining item, so I'm going to go to a user, over to my test jump label, choose next, and then the comment in this one I'll just say abort and say set, and then the label I'm going to make it 99999. So set that and say finish, and in this case under the miscellaneous I'm going to set its base priority to be something a lot bigger, maybe 100. Say set, apply and OK, and we put it all the way to the end of the sequence for our abort process. So now this is at the bottom there. We can rerun through our machining sequence. Go to our NC code, and then if we scroll all the way to our bottom of our program, we should see we've got an abort N9999, and that is where the program will jump to if it fails the other operations. So once we've created those features, we can then turn on the rest of the operations. So for example, the group 10, and also we've got some additional ones such as the continue label for the next operation. Playing through the sequence, then got our part like so, and we're ready to throw that on the machine and run through that sequence.